Thank you so much, Jeffrey, for that introduction. And thank you, Dr. Chang and his team for including SBCSS in this work. And second, for being STEAM warriors. I mean, we all need to push forward and support and take action. As we all know, our state of California has a new call of action, and that is literacy, improving literacy across our TK, actually early literacy, all the way through our K-12 systems. So with that said, that will be the topic of discussion for this panel. And it is my honor to introduce our panelists, which is our first one, Dr. Eduardo Mosqueda, Associate Professor in Department of Education at UC Santa Cruz. We also have Dr. Susie Dolinson, Education Programs Consultant, Professional Learning Innovations Office, California Department of Education, lecturer and Department of Teacher Credentialing at CSU Sacramento. And then we have our practitioner, our Bridget Barnett, our teacher, a 4-5 teacher from Date Elementary School in the Fontana Unified School District. So we'll go ahead and start. We're going to start with 3 questions, and our panelists have all created a short visual to share with you guys the work that they're doing under this umbrella of literacy. So our first question is, how does STEAM integration play a vital role in improving language and math literacy? And how is this focus aligned with California state priorities to accelerate learning and improve literacy skills? And what evidence are you seeing that it's working? So we'll go ahead and start with Dr. Mosqueda.
Thank you, Dr. Pierce. And I think I'm going to try to share my screen. So hello, everyone, and welcome to our panel. And I just wanted to share a few thoughts about some of the work that I've been doing in mathematics, and have recently been invited by Dr. Chang to think about the language and literacy integration with an emphasis on supporting English language learners in mathematics and computer science. And so I first wanted to kind of give us all a sense of where sort of my thinking comes from. And this is an example that I like to use to try to sort of center us on this issue of promoting the development of language and academic literacy for English learners. And so this actually comes from a study where a young girl, Janet, in middle school was asked in a group to find the area of a triangle. And when the teacher came around to her group, she calls on Janet. And Janet was an English learner, and her response in English was, "Because we count the squares." Now, all of us that are teachers that have been in classrooms know that that response, "because we count the squares," does not adequately capture what we mean by area of a triangle. But then one of the researchers that was bilingual approached Janet and asked her in Spanish. And this was Janet's reply in Spanish that was translated into English. "We think the area is 18 squares. We counted the whole squares and got 12. There were some incomplete squares left over. Some were big, others were small. We joined the big ones with the small ones and got 6. We added 12 plus 6, and our result was 18 squares." Now, the second response that Janet wasn't able to share with her teacher, the person that assesses Janet's mathematical knowledge and skill, does reflect a deeper understanding of what we mean by area of a triangle. Unfortunately, in spaces where there's no support for English learners, that knowledge, that understanding, that reasoning can oftentimes get lost. And so in computer science and in other STEM areas, we know that we have to pay attention to language as well as pay attention to practices that promote the learning with understanding, the development of proficiency in math, also in computer science. And our goal should be to try to find that sort of area that captures sort of an overlap or a sweet spot, if you will, that allows us to really capitalize and simultaneously teach content and the language of the academic classroom. So in mathematics, for instance, and this was from a study that later then was developed into the Common Core mathematical practices, they came from these 5 practices for mathematical proficiency. So I like to use these because they're simpler. But the idea is that students should develop at least 5 dimensions of understanding math in order to develop proficiency, that they have to develop reasoning, they have to develop strategic competence, or the ability to solve problems and to represent abstract problems, that they have to learn math with understanding and develop a productive disposition that really understand that math is useful, and also fluency. We want them to be able to do the arithmetic. And so these mathematical proficiency practices, to me, have been kind of a driving force for understanding here at UC Santa Cruz how our future teacher educators should be thinking about developing lessons in math, making sure that the activities allow for students to develop conceptual understanding, that students are computing, that they're showcasing their reasoning. And of course, that math is useful, and that they can have sort of a belief in themselves that they can do it. And in computer science, there are 4 critical themes in the California computer science strands or standards. And these strands, or these computer science themes, are equity. So we want to make sure, we need to understand that the implementation of computer science standards is itself, an issue of equity, inclusion, and social justice, because we know that there's a long history of denying access to students from low-income communities, students of color. And so thinking about issues of access and opportunity should be at the fore of implementing these computer science standards. That computer science, focuses on powerful ideas that can be used to solve real-world problems. I think that's one of the overlaps there, that through math, we also want kids to use math to solve real-world problems. And of course, the focus on an emphasis on computational thinking, that we want students to be able to represent problems as algorithms or steps that can be then executed by a computer, and that computational thinking can be used to understand abstract ideas, to model, or even to decompose or intersect, and that these intersect with computer science concepts that include algorithms, automation, and data visualization. And then there's also the breadth of application. As we have seen from a lot of the examples that have been shared at this conference, there is more to computer science than just the coding. And so then the third sort of dimension of integration then are language and literacy teaching practices, that students, as they're learning to code, as they're learning to make connections between computer science and mathematics, that they're also learning the language of the mathematics of the STEM classroom, that teachers are integrating activities so that students can develop mathematical or STEM discourse, that students are also developing literacy, and for English learners, biliteracy. And of course, mathematical vocabulary. It's very hard to articulate your understanding and your reasoning if you don't have a command of the academic language in STEM. And so what we've been working with teachers on is really thinking about, so what does math discourse look like when we connect it to math or to computer science? That in classroom activities, that students should be making connections to the home or to community funds of knowledge, that students are interacting and collaborating, that they're generating arguments and explanations, that they're also actively listening, being able to engage in discourse and talk also means that you have to be good at listening and taking in information. And of course, being very transparent about strategies that promote math discourse. By mathematical literacy, we talk about getting kids to write, getting kids to talk, to present, to share. And that can be done through math diaries, learning logs, sharing written responses, incorporating books of stories or real world problems, and also teaching students how to navigate textbooks. And finally, mathematics vocabulary, and with English learners in mind, that we pay attention to the language demand of problems of our lessons, that we identify, sort of tier, what folks sometimes call tier 1, tier 2, and tier 3 words. Tier 1 words being everyday words. Tier 2 words being vocabulary words that cut across content areas, like explain, summarize. And then tier 3 words that are located within the content area, that we teach kids strategies to make sense of vocabulary by paying attention to roots, suffixes, prefixes, that we pay attention to cognates, that we can connect what we're teaching with what students may already know in another language. Cognates are those words that sound similar across language, like programar and program. So those are cognates. There are other strategies that we can use, but the idea is, then how do we integrate these strategies as we think about the teaching and learning in computer science, and perhaps the integration of math and computer science with these language and literacy practices. And so on our first day, Jeff walked us through this example where he was, sort of using a panda to walk around this grass field that's embedded in a Cartesian coordinate plane. And the idea here, it really got me thinking about how in this lesson, how important it is to think about how do you integrate vocabulary so that as students are learning about area, which is a critical concept, not only in algebra, but also in calculus. When students start to integrate, the idea of integration and finding the area under a curve, that we're able to use technology to make those connections from early on. And again, the ability for Rohrer-Blockley to provide visual representations of very abstract concepts. I think we need to capitalize on not only the mathematical, but also the linguistic advantages and the development of computational thinking. Having kids sort of use a loop to generate a more sort of efficient way of getting the panda to form a triangle. And like I said earlier, using the speak function to then also to have kids reiterate the vocabulary and perhaps even their understanding. Thinking about discourse, math, and computational thinking, we can, for example, even generate a simple problem where a robot is moving across a Cartesian coordinate grid, taking 4 positive steps horizontally, and then 4 positive steps vertically, and sort of generating a pattern and asking kids to describe a pattern. And for English learners, maybe even using, to my sort of second point, we can guide their response using sentence frames. So we can sort of lay out the language so that students begin to, the language that can model this academic or math discourse. So beginning at the origin, the robot travels X inches along the X-axis, then another blank inches along the Y-axis. And the reason why this is important is that developing that language and that understanding to make sense of what the robot movements is also introducing them to the language of constant rate of change, which is a slope. And that same language becomes useful again in statistics when students are interpreting a linear function, a linear regression. And so these are ways that we can build on the mathematical and the computational thinking, and as kids develop and are able to speak like scientists, like mathematicians. And there are multiple examples in Rohrer-Blockley where you're asked to program and to visit different sites. And I think these create different opportunities for literacy, to have kids write, to explain, to even get creative about what the robot was doing at each of the sites, at each of the stops, that maybe they can even talk and describe to a partner how they solved the problem, to showcase and develop their reasoning. And again, using the speak feature to have robots tell the story, and maybe even in multiple languages, so that kids know and they feel that even if they talk a language other than English, that's welcome. and that we as teachers are going to build on what they know, not only in math, but also in terms of the knowledge and skills that they bring in their native language. So to conclude, I think it's really critical to demystify coding and mathematics. I think it was in the beginning, our keynote speaker, Dr. Jimenez, talked about how many kids feel that math is too hard. And so engaging our students in this work can help demystify the math and the computer science. That a focus on language and literacy can benefit most kids, not just English learners. That when we explicitly teach math, science, and computer science, then we also teach the language of those content areas. I think it's also important when we think about English learners to leverage their native language, that we can build and integrate what students know and understand in Spanish, if that's the one of the languages spoken in your school. And then, paying attention to vocabulary. And, as I said earlier, in my earlier example, that, cognates are important, but also we also should remember that that some words like program are multiple meaning words. So those are other strategies that we can use to generate more access for our English learners. And that we need to also pay attention to the non-academic benefits of computer science engagement, achievement, motivation, engagement, and retention in STEM. We talked, other folks have shared how students increase in their attendance. I mean, there are so many non-academic benefits that we need to really pay attention to that a lot more. And finally, encouraging students to create their own projects and not only work on pre-planned examples. I think a lot of these things can really promote engagement for English learners, but for all of our students, particularly those that are struggling. And so I'll end here and send it back to you, Dr. Pierce.
Thank you so much. And I do appreciate you really emphasizing, the piece about science of learning, right? If students are interested, they build curiosity, they build motivation, and they build engagement. And that all students have, I think there's a misnomer that, people feel that literacy only belongs in ELA. We all are teachers of literacy, right? And all kids. And if you look at the definition of literacy, it's not just reading and writing, it's speaking and listening. It's the language, it's our language, it's our communication method. So we all have a responsibility in that. So thank you very much. All right, so Dr. Susie Tollinson, what would you like to add in terms of how this can play a vital role in improving language and math literacy?
Oh, I think this is all powerful. Thank you, Dr. Pierce and Dr. Mosqueda. I actually started, I don't know if you can see this, it's kind of hard to see. I started back in 2012 when this was the original robot used with the CSTEM program. So I'm going to take you back. I'll put in my PowerPoint here. I think that, let's see, if I could have the screen, I'm going to stop your screen, Dr. Mosqueda, if you don't mind. If that'll share up. Did that go? Okay. Yeah, so I really appreciate the opportunity to come out and speak. I am with the Department of Education. I'm not speaking on behalf of the Department of Education. I am speaking on behalf of just working with the program and with the CSTEM program from those early beginnings. So thank you again for having me here today. And let me just see if I can get this to start. All right. So essentially, piggybacking on what Dr. Jimenez had started with on those literacy disparities and looking at our state assessments, when I looked at the disparities in 2012, they were no different from what they are today. And these are the most recent. When we look at it, the breakdown from both our ethnicities and our socioeconomic status, you can see that it illustrates those disparities throughout the years, and it continues to illustrate those disparities. And when I came into the project with CSTEM, it was a way to increase the rigor. And let's see, this is not moving. Okay, so it was a way to increase the rigor, and I worked on a project with Dr. Chang in 2012. I was the only English teacher to work as a fellow under Dr. Chang back in those early stages. And we published the outcomes of integrating coding and composition in 2019. what we did was, or what I worked on under Dr. Chang, was to align composition, academic composition, with coding, the languages. And it was, as Dr. Mosqueda pointed out, that emphasis on language is not something that can be ignored. And as you pointed out, Dr. Pierce, the literacy is not in isolation, it is across the curriculum. And the way that I posited it was that if language arts is directly connected to computer programming, and computer programming is then directly connected to math, then language arts is indirectly connected to math via path over computer programming. So in my course, when I brought this back to my classroom, again, I was a high school English teacher at the time, and I had the students conduct a research in social trends. They used the computer programming to collect data and to generate these graphs that you see down here. Using the coding, they had to carry out or conduct mathematical computations to put in the codes, and then also establish the correct processes to make it develop the graphs that they needed. And so it was that practice. And I found, what I heard from Hacienda was that students who might not necessarily have academic proficiency in other areas are attuned to coding and attuned to the mathematical concepts of coding. And so what I found was that my students who were at that time really into the gaming and really knew technology well, but couldn't write an academic essay, once they were able to code, it enhanced their writing, and I'll show you how. So what I did was I had taken just basically the alignment between both academic composition and coding, and we know they're all basic literacies and all of these areas here that they have in common. But when we look at the actual alignment between programming and academic composition, what I did for my students was I showed them that with the header file, that would be the title of your composition. Your declaration of your variables would represent your thesis statement. With your initialization, that would be similar to your introduction. And processing would be your body paragraphs, with the termination being your conclusion. The alignment of the syntax showed that quotation marks to print a statement were similar to the quotation marks of making a statement, or the semicolon that actually completed a command statement was aligned to the period that completes a sentence. And so just this basic alignment to allow them to take something that was more, I would say enjoyable, but more engaging to them, which was the programming. Just that simple alignment allowed them to, now when they wrote their academic essays, when they actually wrote out the reports to finalize the stage in this research project, it simplified that process for them, because rather than focusing on academic writing and the process and the disconnect that they had with engaging in academic writing, they were now connecting it back to programming, and that alignment to writing a program into writing an academic essay. So it was pretty powerful in terms of the outcomes. In my next steps, what I am working on is a parent engagement, and that seems to be a missing step. We have the students engaged, we have the programs are in place, and since the MOBOT that I worked with many years ago, the progress that the CSTEM program has made has been immense. And so what I'd like to move that forward into taking it a step further into incorporating CSTEM program. And I'll be publishing a strategic plan to align some engagement inclusive practices with our parents, either through the school site council or through ELAC and other required activities. So some modules I was proposing with Dr. Chang and we're looking at modules in math achievement. This is working with parents. So using the CSTEM program to introduce the program to them, to the parents, where these are already implemented in the schools, and math literacy, ELA literacy, promoting reading and writing through interactive text. All of these are components of the CSTEM. What I see now has advanced to in the programming that Dr. Mosqueda showed examples of, and our teachers have showed examples of, that it moves beyond math, that it does literally move across the curriculum, and we can show these components across the curriculum to our parents and share it with them, including social science. And then I had 9 modules set up just analyzing the program and the advancement in the program, including the technology, science, engineering, and robotics. So that's kind of where I would like to take this moving forward. Again, not in my role with the CDE, but outside of my role to continue to move forward with working with CSTEM. So that's the language and the language and the literacy speak for themselves. It is across the curriculum. It cannot be ignored when we talk about the need for the use of not just the vocabulary, the sentence frames, and how we engage students in the learning of math. I like to use the example of even the simple word plot, where in language arts, we're always teaching students how to plot a story. And then we go to math and they're plotting numbers on a graph. And in history, they're plotting events on a chronological timeline. So the language itself is cross-curricular, and we need to simplify education in terms of allowing students to recognize these patterns across the curriculum to assist them. And the CSTEM Center has really developed a all-inclusive program that allows that facilitates that process. So thank you.
Thank you so much, Dr. Dolanson. As you can see, we're taking, our state initiatives, which is the focus on literacy, improving literacy, and taking the focus of computer science and access, or equity and access, and blending the two. So our final panelist is our practitioner, Bridget Barnett. How about you share with us what evidence are you currently seeing in your classrooms that goes to show what Dr. Dolanson said and Dr. Mosqueda shared, that shows us or proves to us that it is improving literacy skills?
Okay, let me show my little thing that I have. Let's see. Is it working?
Yep.
Okay, good. So just mine's real quick. Let's see. Okay, so I took this to mean literacy basically means that you can understand it. Okay, it's how we consume information, and that's kind of just basically what STEM is. Okay, let's see if I can get this to change. We don't use Google here, so this is kind of interesting to me. It won't change.
You should see at the very top, at the very right-hand side, it's the slideshow. Click on that.
Okay, thank you. Beautiful. Nice. And then there we go. Okay, so it's acquired through learning. We use as teachers have to inspire the kids. If we just talk to them, they're not going to get it. And so the Robloxly has been really fun in my class. I've been using it in my classroom with the fourth graders, but I've also been doing it virtually with my own grandchildren. And we're ranging it from first grade all the way to high school. I've got 7 of them, and they all asked me if they could do it. So I've been having a lot of fun with all the different grades. It's very interesting because it's student generated. The students get to figure out what they're going to do or how they're going to do it, and they talk it out with each other. I have a non-English speaking student. She doesn't speak any English. She actually is going farther along in the Robloxly program than a lot of my English speaking students, because she can figure out by words that are consistently going on and on and on, she can figure out what she's supposed to do. Just Monday, I got a new student straight from Mexico City, and I enrolled her onto Robloxly, and my first student shared, I asked her, I said, can you show her how to do this? Let's see, where is she? She already passed 6, 7, 11, 17 different assignments on Robloxly. 17 different assignments on Robloxly. And she's excited about it. She goes, can I do it when I go home? Well, in Spanish, she asked me. And I'm like, yeah, if you feel like you can, go for it. So she's very excited about that. She does not read any English. She doesn't speak any English, but she's very excited about doing this because she can understand a lot of the programming because she's does computers at home when she's doing it in Spanish. So it's very exciting that she was able to work together with another non-English speaker. I wasn't saying anything to her. I was just letting them do it on themselves. And they're very excited about sharing with other people. So I love the way it works like that. When asked if it's aligned with the standards, it's exactly aligned with the standards. It has it where when you go through the curriculum, you can have exactly what curriculum you're going. This is why it's so easy to do with all the different grade levels, is because I can go straight to the curriculum and assign it to each of the kids. I was sharing before with my other grades that I was teaching the students how to do distributed property in math in the traditional way. And I had maybe 30% understand it. And then I thought, you know, I'm going to try it with Rob Lockley. And we did it with Rob Lockley. And it was so funny because I just showed them, you know, just generalized, showed them a little bit of it. And I heard, oh, we know how to do this. This is easy. And they zoomed on that program for Rob Lockley. And kid you not, the next day they took the distributed property test, paper and pen, 80% passed. Normal class is 30% would pass. And I really do believe it's because they felt so confident with being able to do it on Rob Lockley. And it had nothing to do with my teaching skills. It had to do with being able to make that connection with something that is outside of the traditional way, or, you know, being able to take ownership of being able to manipulate something and real life in a sense. So it was exciting for me to hear them be so excited about learning when they didn't realize they were doing it. Like I said, the benefits are so fun. It's just so exciting to hear them saying, oh, this is easy. Oh, you know, I know how to do this. I have one student that constantly asks, can I be your assistant and go show them how to do this if they need help? And I told the kids, you know, I'm going to ask after school, I'm going to have kids come that need help in math, and I might need helpers. Well, this kid right now, he's done all his assignments in Rob Lockley that I've assigned so far. Can I assist the kids in my class if they're not doing after school? I'm like, go for it. You know, you finished all your work. He loves this. So now I have 3 helpers. All of them are like, I don't need help. I got this, you know? So it's really exciting to have them work together, to want to help other kids. They adore the program. This is my granddaughter. She was doing it last night. My daughter took a picture and said, look at this crazy kid. And I think that all the districts should at least, you know, offer it to one or 2 teachers per school and let them try it like they would with a pilot program, and just try it for a year for intervention for math. It's unbelievable how excited these kids get and how excited I get. I was not a coding person. I didn't know how to code at all. Trust me, at all. And now I'm just having great fun. And what's even funner is the science teacher is offering a coding class for orbits or something like that. And my kids go in there and they're like, well, this is too easy. I don't want to go here. Or they'll go and they'll try to do Scratch, which is the program our school has. And it's too easy for them. They're like, this is just not, Miss Barnett, that's like a little kid kindergarten class run. So it's really awesome to see them so excited about the program and are learning from it. I really see a lot of the benefits from this. And they just come to me, Miss Barnett, this isn't making sense. How would I fix this? And I said, well, read me the problem. And they can figure it out just by talking to me without me telling them the answers. And sometimes I'll have a problem with it and they'll tell me how to fix it. And I just got a couple of quotes and those are where I got them from. So that was it.
Well, thank you so much, Teacher Barnett. And I want to give kudos to your school in Fontana Unified School District, because you hit it on the nail. You allowed a student who did not have the language to access, right? And so that is a perfect example of what we should be doing in all of our schools, because sometimes those students, there's a misconception that because they don't have the language, they don't have the capability, right, or the skill to accomplish that. And so thank you so much for allowing our kids those opportunities. And thank you to all three of our panels. I mean, you definitely explained that learning experiences and connections, allowing that, it's the exposure that we should be allowing. We don't need to make experts at kids, right? Sometimes we get caught up and thinking we have to make an expert and they have to have an A. Really, it's the exposure so that they practice critical thinking skills. And I love the word metacognition, Dr. Dolinson. That is a word we should use more often in education, because that's the way we learn. So thank you very much, panel members, and I'll turn it back over to Jeffrey.